Okay, so our last thing for nomenclature is involves something called molecular compounds. They are not, oops, stop that, not ionic. Everything we've done up until now has been ionic. That means they have charges and they drop and swap. These, because they are not ionic, do not have charges and they do not drop and swap. That is really important to distinguish between them, okay? They are made only from two non-metal atoms and they share electrons. Ionic, they transfer. Okay, so these are not ionic. So, they do not contain ions. I'm emphasizing again, no charges. You do not even look for the charges. They are made of two and only two non-metal atoms. Remember where the staircase is. That's how you tell them apart. You're looking for two capital letters only. And they share the electrons. They don't transfer them. There are no charges. You're not looking up the pluses and minuses. You are not going to drop and swap. No dropping and swapping. Okay, these are actually very, very simple. The way you name them is you have to be able to count. Okay, they're named a little differently from ionic compounds. Some of it's the same. So you name the first element, so carbon. You name the second element by dropping the ending. So instead of oxygen, it would be ox. And you add IDE. So that's very similar to what you guys did with the ionic ones. The thing that makes it different is you can indicate the number of atoms of each element using prefixes. Okay, and so the prefixes are listed here. 1 is mono, 2 di, 3 tri, 4 tetra. After that, they start to make sense from geometry. Penta, hexa, you may not have heard of hepta, octa, nona, and deca. Okay, those are the 10 different prefixes. You will have to memorize these. Most of them make sense. It's not quad, by the way. Most people do quad. So the way you name them, literally, is you name the first element. So bear with me. My handwriting is going to kind of be weird because I got to write small. Carbon. Name the second element. Add ox. And then add IDE. And then here's the difference. You have to use the prefixes to tell how many carbons there are. So mono, carbon. How many oxygens there are? Mono, oxide. Now, it gets to be a little bit of a tongue twister with oxygen. So if you wanted to drop that O and call it monoxide, that would be fine. Here's the other thing. You can drop mono on the first element only. Can't drop it on the second one, but you can drop it on the first one. It's kind of implied. So you probably have heard of carbon monoxide before. So that's where it comes from. The name comes from the fact that there is one carbon, monocarbon, one oxygen, monoxide. So we can drop the mono on the first element. So monocarbon monoxide. This one is also carbon oxide. Technically, there's one carbon, so we could call it mono. And there are two oxygens, so we call it di. But again, if you wanted to drop mono on the first element, that would be carbon dioxide. And again, you've heard of that before. So go ahead, see if you can do these. Mono is the only thing you can drop, and you can only drop it on the first element. So if I was looking at this one and I wrote nitrogen, oxide, I have to keep the di, because the mono is implied, everything else is not. So dinitrogen tetroxide, and again, if you wanted to drop that A to make it a little simpler, that'd be fine. So it's dinitrogen tetroxide. Okay, this is one of the major components of smog in LA and Denver, if you ever see that brown cloud hanging over. All right, so this one is sulfur, hexafluoride, phosphorus, trichloride. The next one is pentachloride, phosphorus pentachloride. This one is tetraphosphorus, decoxide, or decaoxide, I don't care. Selenium, mono, you have to keep that mono, fluoride. You can drop it on selenium, and you can drop it on these guys, but you cannot drop it on the second element. Xenon, hexafluoride, and diphosphorus pentoxide. Okay, a couple of things. Oops. Pentaoxide is fine too. Want to point out, spell fluoride correctly. The other thing I want you to point out, look at, is there's only 2 capital letters. Oops, stop that. And all of them are on the right side of the staircase. All of them. That's how you know. Okay? You look at where they're located, and if there's only 2 capital letters, that's how you name them. Writing formulas is actually the easiest thing of all. You write down the symbol for the first one, symbol for the second one, write down the subscripts. Okay? Do not drop and swap. Do not simplify. Okay? Just write them down. And you're done. I mean, let's not make this any harder than it needs to be. So, yeah, don't simplify, don't switch. So, nitrogen triiodide, nitrogen is N, iodine is I, tri means 3. Done. That's it. Don't do anything else. Don't look at the charges. Don't do anything. Just write down the numbers. Sulfur is S, Cl is chloride, penta means 5. Done. Don't switch. Don't look at the charges on the periodic table. Triphosphorus monoxide, P3O, and if you wanted to write a 1, you could. Oxygen difluoride, OF2. Dichlorine heptoxide, Cl2. Oxygen 7. BCl3. Now this one in particular, go ahead and see if you can do that one. Remember what tetra is. It's kind of tricky. P4O10. That's the answer. Not dividing everything by 2 and getting P2O5. That would be diphosphorus pentoxide. It is not that. You do not reduce. You do not switch. You do not look at charges. Okay? Iodine heptafluoride is IF7. And xenon tetrafluoride, XeF4. Okay? 2 capital letters, all nonmetals, and no drop and swap. Okay? It's really simple. People have a tendency to get these messed up, and they're so easy. I'll put a little summary